Let's look a bit closer into methods. What are method signatures? What are parameters? What are types? And how are these all interconnected when we're working with Java and Greenfoot? So let's start looking in something that I've been working on in the other videos. So if we look in here, we can see, for example, this is just JWorld. We implemented something that will, when we reset, we have two elephants, Eric and Enrique, and a small dog called Doge. And now I want to explain how all this works. What are all these parentheses? What are all the things in here, and so on. So basically, all classes have methods in them. They don't need to have methods, but normally they have at least one method or more, because the methods are actually what makes them work. So if they don't have any methods, they're not doing anything. For example, this potato has only one method that does nothing, so it can't do anything. It just lies there. So what is all this that we see here? So this is the class signature for the potato. It says it's public, it says class, and this public private, yeah, I'll look into that later, but it says class, meaning it's a class. It's a potato. This is the name of the class. We can call it anything we want. And it says it extends actor, so it inherits from the actor class. So within any class we have these methods, and in this case there's one method. It says public void act here. The parentheses here will tell Java that this is a method, because we can write something like private, we did that before, int acts. So this is an instance variable. And the difference is that it doesn't have any parentheses here. So whenever you see parentheses after something like private or public and a type, then you know this is a method, and Java knows that it's a method. So this is actually a method in Java. And we call this the method signature, meaning the things that we need to define in order to have a method. This is called a class signature. So this is the method signature. In this case we have, it says public. Public has to do with other classes. When they talk to this potato class, should they be able to use this method? In this case the answer is yes, because JWorld in this case knows about the potato here. So whenever I put the potato here and presses act, it will try to call the act method on the potato. So if the potato doesn't have any act method, of course it cannot call it. Also, if I make this private, it won't work, because it needs to be public, otherwise other classes cannot access it. So we have difference between public and private methods. And normally we have them public, but in some cases we want private methods as well that we only use within the class itself. I'll show you example of this later. So public first, we define that it's public, then we define void. Void means that the act method doesn't give anything in return. It just does whatever is inside of this code. Doesn't calculate anything and return the result. So there's no result of this method. So you can say in mathematics you have something like a function, and a function always returns some value for some input. In this case this doesn't return anything. So it's just doing something and not returning anything. And that means the world will not expect anything to come out of this other than whatever happens in here. And then it just have these two parentheses signifying it's a method, and then the name. And we can choose any name we want, but in this case, of course, if we want it to work with the JWorld, it needs to be called act, otherwise it won't work. Okay, So let's try to do our own method. Let's try to combine some things to do something. So let's say that this potato should kind of rot over time. So let's create an instance variable called rot level. So I'll just say private rot level equals 0, something like that. I'm missing something to the signature for this here. I need to define the type that rot level needs to be. In this case, I'll do integer, which is a number, and I'll set it to 0. So whenever I create the potato, it will have a rot level of 0, and each time we act, we want it to count this rot level up so that we know how rotten the potato is. So let's go into the act method and try to do that. So we're just going to say rot level equals rot level plus 1, like that. So now as time goes by, let's put a potato here, run the game, and inspect the element. We can see the rot level is 48. So now we count how much time it's going, how big the rot level is. Okay. Another thing we can do in here, we can also check to see if the rot level is high or something like that. We could do something. But before we do that, let's just try something else. I want this rot level within the act method. I want to show how we can put that in another method. So let's say I want this rot level, instead of having this code, I'll just cut it here. Instead of having this code, I'm just going to write increment rot level. And I will use parentheses because I will call another method from in here. And then down here I write private void rot level increment rot level, and I will use parentheses to say this is a method. So now I created a private method that I can only use within this class, and I put the code in here. So now there's no difference whatsoever from before, because when the program goes in here, it will go to the act method. Whenever it acts, it will go here, see, oh, I need to call this method here. I just need to jump down here. So it jumps down here and does this. But it makes it a bit easier to read this, right? We could also have another method, like we could say increment and then check rot level. So we can create another method for that. Private void check rot level. And this method could say if rot level is above 5,000, potato then the potato is rotten. These are just comments. And then I create, in here I say if the rot level is above 5,000, I want the potato to disappear, something like that. I'll just write it as a comment like that. So now we increment the rot level, and then we check the rot level, right? And then we could do something. For example, we could make the potato rotate potato, and create another method for that as well. If no one from the outside needs to use it, we can just make it private, and that would be the best thing to do if no one needs to use it. Like that. Rotate the potato and we'll just say turn 7. So it will turn 7 degrees to the right. Let's see what happens with our potato now. Kind of turns. And also if we look inside here, inspect it, we can see that the rot level is 100 and stuff like that. So it's kind of working. So this is how we can we can take our code and put it into smaller bits and making it easier for us to read the code. In this example, these are quite simple, but oftentimes one of these methods will be like 20 or 40 lines of code, and then it can be a big good idea to do something like this. If we look in here, this is an example that was installed with Greenfoot. We can see there's here, for example, the ACK method says process keys. If we look to that method, it actually has all this code. Basically, we could copy this code up here and write that instead of process keys, and then apply gravity. We could take that code as well. Where is that? Here. Copy that, move that, copy all the other stuff as well, copy it up there, and then just have everything in one method, and it would be almost impossible to read and understand. So this is why we don't do it. But if we only have one line of code like this, oftentimes we would not put that in a method by itself. So, but it's just to show the example. So that's it. Another thing we can do, we can sometimes have something else than void. So for example, we could have something that would get the x and y value, for example, is a good example of that. So on any actor like the potato here, there is there are some different methods we can see here, and one of the methods is one called getX. And what we can see here is that it says int over here, and that actually means that it returns a number. So if I write getX, it will actually return the x coordinate for the potato. So getX will be equal to the x coordinate. So in this case, let's see, if I put potato here, just need to fix it. So if I say inspect here, we can see the x value is 272. So if I write getX for this potato here, let's try it, getX, I actually get the number 272. So we could use something like this. For example, we can get, let's say the elephant is looking for the potato. It can use the getX and getY for getting the coordinates for the potato and walk towards that potato if that was what it wanted to do. Something like that. So that's kind of the interesting part about that. And then the signature would look quite different. So then we could write something like private, or if we wanted to be public, anyone else, we could also do that, public. And then we would write something like int, saying it returns an int. And let's say in this case get some number. So this is a method that actually returns something. And what we need to do in a method that doesn't have return type void, we need to actually return something to whoever calls it. So if I up here write get some number like this, I expect something to come out of that. So I could do like this. I could say int x equals get some number. But there's a problem here. It has a warning, or there's a problem. We can't use this code because we need to actually give some value back here. And I'm kind of also implying in the name that it's just some number. So I'll just return some random number. Not random really, but this number, 1337. And that will then go back here, and x will be 1337 because that is what's coming out of this method here. So when the code goes here, it goes first, it says whenever I act, let's make a potato. So when I click act, it will go here, increment the rod level. That means it will go down here, do this code. It will then check the rod level, do down here, do this code. Then it will rotate the potato, and that will be going down here, doing this code. And then it will set x equal to some number. I'm not sure if we can see x in here. I wouldn't count on that now. So this gets some number. We can't see that when inspecting it, but it actually means that the x coordinate of the potato will be saved into this local variable here. We cannot do that with something like rotate the potato because the return type is void. So whatever type is here, int, must also be here. This is important, so I can't change this into something else. Like we have something called double, which is just a number with a comma in it. And we can't do something that is not, because it's not the same type. So it needs to be exactly the same. Another thing we can't do is I can't do something like, let's just take m equals, because you cannot assign anything to void. So if it says void here, you cannot assign. So it says rotate potato, and because this is void, this is illegal to do this. Very illegal. So back to that. So this is kind of the signature. So what you do first, the first thing you write the visibility of the method, that is public or private, and then you write the type, and then you write the name, and then you do the parentheses, and that's it. So you always need to specify visibility and type and name. You can also do something else. Sometimes you will see something else. Let's just look at the doc here for a second. And we can see there's one called turn, where there's kind of like an int here. It has a void as return type, but it has int inside the parentheses. So we can actually put something here inside of these parentheses. So let's try to make a method that can multiply two numbers. So public and int multiply, and I can write int here and int here. So if I want to multiply two numbers, two integers, and then return the result, I would need a method like this. So this method is public, everyone can use it, and it needs two integers. We need to name these. These are called parameters. So we can call them n1 for the first number and n2 for the second number. So we need to name them. So this is called parameters. This is something we give to the method so that it has some data to work with. We also saw that in JWorld, for example, add object. We have three parameters, the dog itself and the coordinates for the dog, and the same with the elephants. So this one, if we wanted to multiply, we can say we can make something, we'll call it result. This is a local variable, and we will say result equals n1 multiplied by n2. So now we have the result here, but we need to return the result as well. Because if I write something like multiply 3 by 5, I need to have some values saved into this local variable here, and that should be this result value here. So there's a special keyword for that called return, the same as I use down here, but in this case it uses the two parameters to calculate the result, something like that. So this would be a way to go about it. In this case we have two parameters and a return type of int. Sometimes we have void as return type, sometimes we have there's no parameters here, sometimes we have multiple parameters, sometimes there's a lot of them, sometimes these are different types. It could also be like one of them could be like actor or anything else, and there's a lot of different types that we can choose from. So this is it. So in this case, this res here would be multiplying 3 and 5, so it should be something like 15. Yeah. So this is basically what we want to do. So first we call this I called it visibility. The real name for it is modifier, but you can call it visibility. It says public or private. We take the type, we take multiply, which is the name of this method. We imply it's a method by putting parentheses, and then we put two parameters inside of it so that you will know you can have that data to work with. And then we use the return special keyword to actually return the result. Maybe some of you are thinking, couldn't we just take this and put it down here and then remove this line completely? The answer is yes. So, but you can also do like that. It was just to show everything, the parameters, local variable, and returning the local variable as the result. That's it.